because it's going to be using the whole thing, right? You can just start out with one partition. You can say shrink. So it's going to say that, now remember, OS installers are read only, right? You don't ever write to it. Like, imagine you're installing Windows from a DVD or a CD. You're not writing to that DVD when you're installing it, right? Ever. So you don't need any free space on the installer once it's there, because there's no swap space used on that disk. There's no swap space necessary. All you're doing is reading files from that disk and writing them to your internal drive, right, when you're installing the OS. So what this is going to tell me is, okay, this is my size of my available shrink space. How much do I want to shrink it? I want to shrink it by as much as I possibly can. Now, if I'm working on now this is obviously very different than the actual amount of free space. And the reason for that is because, remember, that I imaged what onto this disk?
On a hard drive.
What was it though? Was it a hard drive?
A solid state drive.
It was an SSD. Does fragmentation exist with SSDs?
No.
No. So does it matter where you write files on SSDs?
No.
No. It writes them to available free cells. Now, because that was a 256 gig SSD, there were files all over the disk. So everything wasn't stacked up perfectly in 45 gigs of the first cells on the SSD. So they did happen to be within the first 126 gigs of the SSD. You can see right there that I'm only able to shrink this down to 126. I would need to defrag it first in order to shrink it down all the way to 45 gigs, which is what we just saw in C properties, is how much space is actually being used. You wouldn't have to do that on a flash drive because it's going to shrink it all the way down to however much space is left, and then it's going to use the available cells. The physical representation of your files on the cells on the flash drive do not have to correspond to the partition block spaces. They're still going to be showing up on your partition scheme. So once I defrag this, I could go ahead and shrink it down all the way to 45. But all you would do after you image your first operating system onto the flash drive would be to shrink it down as far as it can go, and then image your next operating system onto the free space. And then shrink that one down as far as it can go, and then image the next one onto the free space. Shrink that one down as far as it can go, and repeat.
Is shrinking the same as defrag for SSDs?
No, not at all. There is no defrag on
SSDs.
SSDs because it doesn't matter where the files are located.
So it's called shrinking then for SSDs.
It is called shrinking because you still have available space on the disk. But if this was still the SSD that was in there and not this disk, I would not have any way of knowing that those files were scattered around the first 126 gigs, even though they only occupied 45. Instead, it would tell me that I'd be able to shrink it all the way down to 45, because it doesn't matter where those files are located on the disk. Like as I mentioned, the logical means, the software representation of what I see, where those files are on the disk, doesn't need to match the physical representation of where those cells happen to be placed on the NAND flash memory on the solid state drive. So I could shrink it all the way down to 45 gigs and that would be fine. Now, there is a concept known as over-provisioning on SSDs, which is very important. And you all should have gone over that in 8+. But we're not going to talk about it now because we're...
Okay, one more question real quick.
Yeah.
So shrinking is like decompression of your files or
No.
together?
All we're doing is we're going to take the disk. We're going to look at how much stuff is on it. So okay, let's just imagine it like this. You have you got an ice chest, and you've got a 6-pack of beer in an ice chest. your ice chest can hold 6 six-packs. You're going to shrink the volume. So instead, you actually are going to resize the ice chest until now it only fits 1 six-pack, and it's completely full. Now you have this air all around it. So if I want to get a new ice chest that's able to store 1 six-pack, I could get it and put it right next to the first one, and that is going to be a new partition that has however much space I gave it.
You just kind of individualize it, instead of making one big one, you just kind of put
Right.
together.
Yeah, or you can think of it as, having a huge trash bag, and, your trash bag is 100 gigabytes, and I'm gonna put, only, 2 bags of, 2 raked shovels full of leaves in there, and that's only 1 megabyte. And so I want to, how much space do you have left? You have still another 99.9 gigabytes left in that bag. Now, if I tie that bag off, and close it, then I'm shrinking it down to the 1 megabyte or whatever that would be. And I still have all this other now unpartitioned space left over to do anything else I want. Make sense?
What was it where you said we should have studied an A plus?
Over provision.
Over what? Over provision?
Over provisioning on SSDs. Now, it's not really something that you're going to find on the exam. David, you didn't see any questions on SSD over provisioning on the exam, did you?
No.
I wouldn't worry about that.
Okay.
But it's an important concept to be aware of in terms of how SSDs work. But we're not going to cover that right now. I'm not going to actually shrink this because I would want to deep fry it first. But you get the concept of that. Any questions?
No. You want to get me in trouble, James?
I think Tinkerbell has a question over here.
I'm thinking of a question, James. A good one.
Google your tough question again.
Right? Yeah. I'm gonna Google it before I make it. Okay, guys. What time is it?
It's like 12.
Like 12. Right on, brother.
Yeah.
Somebody tell me. So I'm back on the HP. Is my boot disk? Is my Windows boot disk legacy boot or UEFI boot?
UEFI.
How do you know?
Because the
Right
EFI.
there. Go to the left.
It's the UEFI. Because of this.
Yep.
So I've got 3 SSDs in this machine, in this little machine over here. This one here is it's a 256 gig SSD. It's got Windows 10 on it. This is a 500 gig SSD with Mac OS on it.
Likewise.
And this one has an EFI partition that's 200 megabytes, which is the size that Mac OS makes their EFI partitions. And this one also has an EFI partition, but this has no operating system installed on it. Instead, this one's formatted as exFAT because on the Mac, the primary partition uses the APFS file system, which Windows is incompatible with. So in order to, that would be inconvenient, switching back between the two. I'm writing files, but then I can't access any files from Windows that's on the Mac OS primary partition. So instead, I use this third SSD for that purpose. And it's formatted as exFAT for compatibility reasons.
So you can transfer from one computer system to the next,
Yeah, or, I mean, so I do have HFS Plus drivers installed on Windows here. So I could write to Mac HFS Plus volumes, also known as Mac OS Extended volumes, which was used with operating systems 10, 12, and earlier. 10.13, they went to APFS. You can choose between the two. But if you're using an SSD, you're way better off using APFS than HFS because it's so much more efficient. With APFS, you can have 10 copies of a file all around your disk, and it's only going to occupy the space of one file. And it's much more efficient than NTFS or HFS. APFS is the most advanced file system out there. It's not on the A+, but it's on the 1001. It's on the next version of the A+. So APFS is a superior file system. Windows needs to make a lot of changes to NTFS because it's very outdated. But it's still pretty good for what it is. And I also have an NTFS driver on that Mac OS installed, so I could write over to the NTFS partition. But I don't generally do that. Instead, I just use this third SSD for anything that I might want to share between the two. And I also have that synced to the cloud on that third SSD. So it's just more convenient. It has an EFI partition because it, even though it's formatted as exFAT, it has an EFI partition because it's using what partitioning scheme?
GPT. GPT.
GPT. Your two partitioning schemes that you need to know for the exam are GPT and MBR. Yeah. EFI just means extensible firmware interface. That's either a type of boot or it's going to be one of your partitions. If it's using GPT, it has to have an EFI partition on the disk. Now the only reason, like I said, this has no OS installed on it. So the only reason this has a 200 meg EFI partition is because I formatted it on Mac OS using exFAT. If I had done that on Windows instead, it would have a 100 megabyte EFI partition. GPT stands for GUID, G-U-I-D, partition table, and GUID stands for what?
You know? Graphical partition table.
No.
No.
No?
GUID.
Globally unique identity.
Or GUID, yeah.
Globally unique identifier.
She Googled it.
It's different than the universally unique identifier. It's different than your UUID.
Good.
Good.
Good partition table. Oh, GUID, yeah. So is that global?
Okay.
Global.
And then down here we've got our, it says CD-ROM. It doesn't identify that as a DVD or W drive, but that's CD-ROM and it says DVD. That's what Windows does for you.
So not, is exFAT compatible with Windows?
Yes.
Of course.
Yes.
Yeah. exFAT is one of the most universally compatible files.
So now, and when you partition, you know, a disk, let's say, you know, you only have one disk, and you make 4 partitions, and you know, one for your OS, and then another, you know, another partition for your videos, and another one for your stats, and then, you know, or something like that. When you save stuff to your hard drive, how do you know where it's going to? How do you know if videos are going to the videos?
Because those will all show up as different hard drives. So, EFI partitions by default do not mount. They don't mount at all. Can you mount them? Sure. You have to mount them if you're going to screw around with them. And if you're going to even think about getting Mac OS installed on a machine like this, or working perfectly with, acting like it's native on Mac, you have to make extensive modifications to the EFI partition and all the contents of that partition.
Can I just clone yours?
You're welcome to clone this one. Yeah.
You said it'd take like, what, 20, 25 hours?
No.
What's you ordered a long time, isn't it?
Yeah, when I wanted to get back into understanding that a little more. I spent a lot of time with it.
Gotcha.
So the first one took maybe, 12 to 14 hours. But then this one took about 30 minutes.
Oh, wow.
So once you understand it a little better, it's not too hard. Okay, let's go next here. Task manager.
It'll take you 25 hours.
Okay, our task manager. So now how did I just access there? Let me do that again. You're going to tell me how I just accessed it.
You right click on the taskbar?
Now, here's the mouse.
Okay.
It's a shortcut, it's not.
Or you use
Control, Shift, Escape.
Right. Control Shift Escape. How did you know I didn't hit Control Alt Delete?
Did I reset it?
It would have locked the screen when you were going to show.
Okay.
Nerding.
Questions on Task Manager. I mean, so with Task Manager, we have our processes. And with our processes, and you had a question earlier, is the difference between a service and a process. So a Windows service is, or any service, is a specific small application that provides a supporting role to some other program or some other element of the program.
supporting role. Okay.
So it's a supporting role. Generally, good? Good? Okay. Generally, with services, go back to services.msc, like we looked at before. Generally with services, they're not able to interact with the desktop. All right, so let's look at a service here like application layer gateway service. And I look at properties on that. Okay, that's not relevant. Let's go down to another one.
CNG.
Here we go. So if it's not one of the core Windows processes, you're going to see this. Allows service to interact with desktop. So you